Okay, circle K has the equation x plus 2 being squared plus parentheses y minus 1 parentheses being squared is equal to 9. Ashton writes a paragraph proof to prove whether point A at negative 1, 4 lies in the exterior of the circle, but he is missing some information. Read his proof carefully and then follow the instructions. So it is given the equation of circle K is at parentheses x plus 2 parentheses being squared plus parentheses y minus 1 parentheses being squared is equal to 9. This means that the center is blank 1 and the radius is blank 2. So I'm just looking over at what I have for standard form of a circle. If you don't have this in your notes, then just scroll up to the key terms and have that open and it'll show you right there. So I highly recommend you having that in your notes. So I'm noticing that this is x plus 2 and in standard form it's x minus. So I'm asking myself, how did a subtraction sign change to an addition sign? And that happens when you actually subtract a negative number. So that would actually be a negative 2. And then we have y minus 1, and that is setting up to be right there. So our center point would be h is negative 2 because it's right here in this, and I deciphered that from this plus 2 because I know that subtracting a negative changes to an addition sign. And then I know that that is a 1. So there's our center point. And then the radius, which is blank 2. So I'm noticing that the r squared is lined up where the 9 is. So I'm thinking to myself, okay, well, what is r squared? R squared means r times r, or a number times a number is equal to 9. So what number times itself is equal to 9? And I know that that is 3. If that is not, like if this number isn't 9, you can always jump to your symbol lab equation calculator and type in 9 equals r squared, and it shows you the steps. This is where you would have to decipher it though, because it gives you 2 answers which are correct. We have to apply the which one is correct in this context. Since we're dealing with a radius, which is a distance, distances are positive. So we would only have r equals positive 3, not the negative 3. So our radius is equal to 3. So then blank 1 is negative 2, 1. Blank 2 is 3. Blank 3. If point A lies outside of the circle K, then the distance of KA must be the length of the radius. Okay, so let's just, there was a diagram in your workbook right here. So if we talked about this and we labeled it according to what our points are, we know that the center point would be K. We know that this would be some other point D, and we would know the exterior point is A, what we're trying to compare. So what this is saying is, if point A lies outside of circle K, then the distance of KA must be blank the length of the radius. So notice here the length of the radius is right here, and the length of KA is right here. So we know that if that radius came right here, point B was actually right here, we know that the length is shorter than the length of KA, since point A is outside of the circle. So we know that the distance of KA must be longer than the length of the radius. So greater than is another way of saying longer. And then the distance formula results in the equation blank. Alright, so I'm going to jump over here to the distance formula, and I know that our center is at K, which is negative 2, 1, and the point we're checking is A, which was negative 1, 4. I'm going to double check and make sure that's correct. Negative 1, 4. Okay, so I'm going to use this calculator, and K is going to be my first point, so that's going to be negative 2, and this is going to be 1. And A is going to be my second point, so this is going to be negative 1, and this is going to be 4. Click calculate, and notice that it gives us the steps there. So then I'm going to be looking for, in blank 4, Ka equals the square root of parentheses -1 minus a -2. And I'm seeing that they did not start with -1, it started with a 2. So that just means that the order of the points was changed. So we can rearrange this for A being the first point, which is -1, 4, and K being the second point, which would be -2, 1. The reason it won't change, the distance will still come out to be square root of 10, which is 3.16. The reason for that is because we have these squares, or these exponents right there. And exponents means you take the number and you multiply it by itself. So a negative number times a negative number ends up being a positive number. And a positive number times a positive number ends up being a positive number. So no matter what kind of a sign is right here, we will always end up with a positive number plus a positive number. So that's why the order of the points does not matter. We still end up with the same distance. So then we're going to jump back. Blank 4, we're looking for the square root of -2 plus 1. That's not matching up quite. I do know though that a negative minus a negative number is an addition symbol. So this is the one that matches. Oh, I didn't fill this one out. Okay, and then, so that was blank 4. Evaluating the numbers in the parentheses results in blank. So I'm just going to be looking for the next one that is lining up there. So then we have Ka is equal to the square root of -1 squared plus -3 squared. And then says evaluating the exponents and taking the square root results in blank. So then evaluating the exponents gives us 1 plus 9, which results in the square root of 10. So we have the square root of 10. And then we're looking, because the length of the radius is blank the distance of Ka. So again, remember the radius is 3. And Ka is equal to the square root of 10, which equals to 3.16. The radius is less than that length. So the radius is less than. So then the question is, point A blank lie in the exterior of the circle. So again, if we were to talk about a circle having a radius of 3, and I drew some point somewhere out here, I drew a line that was 3.16, it would go outside of that circle because it's larger. That length is longer than the radius. So it does lie outside of the circle.